With this video, I am going to discuss about a problem from the chapter Current Electricity of class 12 CBSE. In the circuit shown in figure, EFGH are cell of EMF 2 volt, 1 volt, 3 volt and 1 volt, and their internal resistance, that is the internal resistance of the cells, are 2 ohm, 1 ohm, 3 ohm and 1 ohm respectively. Calculate the potential difference between point B and D, and second part is potential difference across the terminal of each of cell G and H, that is the terminal potential of the cell G and H. Now this is the circuit given. Okay, EFGH 4 EFGH four EFGH 4 battery, that is potential 2 volt, EF 2 volt, 1 volt, 3 volt and 1 volt, and the internal resistance equal to 2 ohm, 1 ohm, 3 ohm and 1 ohm, 2 ohm, 1 ohm, 3 ohm and 1 ohm. This is the given circuit. Now the equivalent circuit I have drawn here. You can see the point BD, across point BD there is a resistance 2 ohm. Here the point BD is there, this 2. Okay. Now since for the first circuit, the first loop, you can see that the battery is the two EMF are oppositely connected, two cells are oppositely connected. So I can write 1 volt, and the total internal resistance 1 plus 2, that is 3, which is parallel to 2 ohm resistance. The second loop here also the two cells are oppositely connected, and the effective EMF is equal to 2 volt, and total internal resistance is 3 plus 1 4 ohm. So now first I consider this loop, and I can write the equation, that is 1 volt equal to from Kirchhoff's law. This is the equation I can write, since 2 ohm resistance I1 and I2 both are flowing in opposite direction. So I can write this equation from the first this loop, and the second loop here also I1 and I2 oppositely flowing. So the second equation I can write this. Okay. Now solving these two equation, I can write I1, that is the current through the first loop, and I2 equal to I1 is equal to 5 by 13 ampere, I2 is equal to 6 by 13 ampere. Then through 2 ohm resistance, current are oppositely flowing and I2 is greater than I1. So I can write that the net current flowing through the close to the 2 ohm resistance is equal to 1 by 13 ampere. So potential drop across BD, that is across 2 ohm resistance, will be equal to 2 into 1 by 13, that is 2 by 13 voltage. Terminal potential across G, terminal potential, the EMF of the cell G is equal to 13, and the internal resistance is 3, current flowing I2 through the internal resistance. So I can write 21 by 13 will be the terminal potential across G. Terminal potential across H will be equal to 1 plus 6 by 13, because H, the yes, EMF of the cell H equal to 1 and the internal resistance 1, current flowing is equal to 6 by 13. So it will be 19 by 13 volt. That will be the answer of the part 2, that is second part, part B.